Good afternoon, good morning, good evening, wherever you are. Thank you very much for tuning in to this AMA. I think I was tweeting about it a week or 2 weeks ago around where Zilliqa 2 is heading. A few people, I guess, challenged us to have the conversation, bring it to life a little bit more. So we decided to get Zoltan to come onto the stage and essentially talk through the future for Zilliqa's blockchain, Zilliqa 2.0, and then have a deep dive into X-shards and what that actually means. So Zoltan, without further ado, do you want to firstly introduce yourself to the Zilliqa community and the wider community, and then go full steam ahead into the future of Zilliqa?
Thanks, Matt. Thanks for having me, and welcome, everyone. I was so much looking forward to this, actually, since the beginning, since I joined Zilliqa last year. It's a little bit more than 1 year ago, working on research which leads to what we call Zilliqa 2.0 being launched at some point next year. And I'm super excited because it contains so much innovation, so much novelty. And I will introduce a few of them today, focusing on two particular topics. But first, back to you, Matt. You're muted, I'm afraid.
I've been on so many podcasts this week, I should really know about that, shouldn't I? The key thing we really wanted to convey was why we have decided on building out Zilliqa 2.0 and why we feel X-shards gives us a competitive differentiator. And it's important for people listening in to understand that. I think we've got a lot of businesses and applications and projects now looking to build on Zilliqa. Clearly, UX, finality, speed, throughput, all that good stuff that people talk about is clearly important. And I think you mentioned it quite well around we want our blockchain to be in the Premier League or the Champions League in terms of the blockchain space. And I think what you've designed and the team starting to build out behind the scenes is definitely going to kind of put us in the top level in terms of where the blockchain space is at the moment. So I think I'm going to hand over to you just now to kind of give everyone a flavor of what Zilliqa 2.0 means. And then as we go through, maybe there's some questions that come through I can kind of ask and we can talk around, or at the end, we can maybe take questions from the floor. But yeah, we want this to be a fluid session. We've got nothing to hide. We're open to answer questions specifically around Zilliqa 2 and X-shards. So Zoltan, the floor is yours.
Yeah, thank you. So what is Zilliqa 2.0? It's not just another upgrade. You know, we have had several upgrades in the past. It will be, I would say it will be our merge moment. You remember the Ethereum merge a few years ago. It's not that long back. It was a fundamental change, and Zilliqa 2.0 will be a similar change in our protocol. We will abandon proof of work and move to proof of stake. This is one of the major changes in the protocol. But there will be a lot of other improvements, like really short block intervals, short block times, like 1 to 2 seconds, just to have the order of magnitude. Fast finality. So 2 subsequent blocks and your transaction is finalized. It's kind of around, let's say, 4 or 5 seconds.
Just in terms of where we are at the moment, Zoltan, can you just give a comparison around that?
Oh, yeah, sure. Currently, transaction blocks are created on average every, let's say, 30 seconds. Some of them take a bit longer, but this is where Zilliqa 1.0 is today. And this will be reduced massively. It will be, by the way, already reduced. I'm quite sure a little bit due to the upcoming upgrade, de-sharding. It will shorten the block interval, but Zilliqa 2.0 will be a different league.
Good to hear. And I think just one question, I don't know if you can give a definitive answer on that. Obviously, TPS always gets asked in terms of what does that look like. Can you give a a ballpark figure around what that will look like, just for our esports highlights chap who's asking, or chap
Sure,
S,
even though it's not the most important indicator, in my opinion, but anyway, look, the actual bottleneck in terms of TPS, if you are talking complex transactions involving smart contracts and not just transferring funds, then as James measured on his kind of local setup, you can execute, let's say, 4,000 EVM transactions per second.
Okay.
On a single chain and single node, without any tweaks and any multi-threading and other stuff you're working on. So we are, of course, about to optimize this and achieve a speed up. But I guess this order of magnitude is doable. But because of the short block times, we do not want to execute much more. Otherwise, we cannot keep up with the desired pace of the consensus. So within this 1 to 2 seconds block times, there will be some time to execute the transactions, and there needs to be time for the validators to agree on the block, to check signatures and do all the other stuff, send the right messages.
I think that should answer the question. Thanks for that, Zoltan.
Yeah, but I will come to that in a minute. We have a concept for how to scale this, so it will not be 4,000 overall and not more. There is a concept called X-shards, which scales this up to actually any number of transactions. But before that, there will be a few other improvements and innovations, like gasless transactions and fees paid in ERC20 tokens, or Web2-like authentication mechanisms. And all of this you may know, or some of you may know, under the umbrella of account abstraction. So one of the major features in ZQ2, by the way, when I say ZQ2, I mean Zilliqa 2.0. This is basically the internal term we are using in the team. So everything you can expect from account abstraction on other EVM chains, we will have as well, or we will have the capability to support all of these features, but we will tweak the account abstraction proposed on Ethereum by implementing parts of it natively to benefit basically of the capabilities of our own protocol. And as you know, today on Zilliqa 1.0, there are basically two chains. There is a DS chain, the directory service, and there is a TX chain for the transactions. In Zilliqa 2.0, there will be many chains. And we call these chains X-shards. There will be one main chain. This is the main X-shard. And there will be actually any number of application-specific, project-specific, or purpose-specific or purpose-built X-shards for, basically anyone in our ecosystem. Let me jump to the next slide, because actually this is already the topic I'm talking about. So on this Zilliqa 2.0 network with a lot of nodes, by the way, Zilliqa 2.0 will be launched with the persistence of Zilliqa 1.0. So at the launch, it will be a kind of a smooth transition. All the existing accounts and balances and smart contracts ever deployed on Zilliqa 1.0 will exist on Zilliqa 2.0 as well. It's only the nodes getting kind of a brand new software to run. On this network, there will be several sovereign chains operated by a subset of the nodes. Nodes can be part of or can join multiple of these chains or X-shards. And an important property of these X-shards is they are highly customizable. So
just on that, Zoltan, so everyone that's listening understands, when you say sovereign chains, what do you mean explicitly by that?
That they are more loosely coupled and independent than the shards are today on Zilliqa 1.0. You know that the shards they they produce their micro blocks which are merged into a transaction block. They have the same consensus, basically the same pace of producing blocks. And this will change with X-shards. X-shards are like really independent chains. They have their own consensus, their own validator set. You can even choose if you operate or want to launch new X-shard, should it be a proof of stake X-shard or a proof of authority X-shard? How should the active validator set be picked? You can specify criteria which the validators need to fulfill in order for you as the user or the application on that X-shard to be compliant with regulations or whatever reasons.
So just so I'm clear then, somebody's asked the question, are we going to state sharding? Is that kind of what we're saying we're doing, or is it something?
Yeah, that's correct. So kind of the technical term would be state sharding. You know, today we only have transaction sharding. In the future, it will be state sharding.
Okay, so if you're thinking about a gaming vertical where they need high throughput, potentially less security, they could spin up the shards on that network and deliver probably a better UX than you'd experience at the moment. I guess we're seeing some chains likes of Avalanche delivering that sort of capability. Is that fair to say?
Absolutely, and they do not need to compete with other applications for the block space on one chain. They have their own block space. They can have more than that. They can have their own block time, for example, and gas limit. So if it's fine for that application, for that X-shard to have longer block times, but for that more gas available to the transactions to get executed within one block, then this is just one of the many settings you can choose. You can have, as an X-shard, you can have your own pricing model. So you can decide how the gas price shall be determined. You can decide or you can choose to use an option called state rent, which requires the contracts deployed on your X-shard to pay for the storage of especially larger data sets they are storing on every node, even if that storage is not being accessed. So otherwise, it would be for free. But if this is a concern or this is a requirement of your applications or of your X-shard, then you can use this option. There will be privacy options, like there will be encrypted X-shards, where the transactions, everything is encrypted and only accessible to those nodes on the network which are part of that X-shard.
Okay, so as you're talking to businesses or banks or financial institutions who are looking to kind of public-private, but still have the kind of the public blockchain, we're essentially enabling that capability. And I think another important component around it is these shards can be spun up in any region that you like. So if you need to have your shards in a specific geolocation or whatever else, we've got the ability now to kind of deliver against that, which is obviously a big requirement in the finance sector.
Absolutely. This is one of the many customization options you have to fulfill compliance requirements in that.
Just one question then. So somebody's asked specifically. So are we calling this a side chain then as a function of what we're doing, or is it something slightly different?
No, we are calling it X-shard because we decided to call it X-shard. Look, others or it's rather a past term, not used that much nowadays, but you could call it a side chain. Others call or use the term subnet. There is another chain that adopt their X-shards supernets, and there are hyperchains, by the way, by another competitor. So there are many terms for similar concepts. In detail, on the technical level, there are differences for sure, but these loosely coupled chains on the same network that share the same network and can share a bit more, have so many names. It depends on the protocol. We chose X-shards as the name for.
I think we all agree X-shard's a pretty cool name. So let's, from a marketing standpoint, let's keep the X-shard. And I think hopefully all of that answers your specific question that you asked.
Yeah, but by the way, the name was chosen before Twitter was rebranded to X. So
that's a good point.
Good. And the very important property of these X-shards is so they will be managed on the main shard. As I mentioned, there will be one special shard, the main shard, and all the others will be kind of recorded and launched from there, and all their properties will be accessible on the main shard. But all of them will be interconnected. They will have some capabilities, or the contracts deployed on those X-shards will have the capability to interact with each other. There will be inter-shard transactions. This is one of the topics I want to talk about today. And there will be also other features like inter-shard state reads. So they are not just kind of independent chains which have nothing in common. There will be some cool features that connect them and allow them to send messages, to bridge tokens, and
so when you say bridge, does that mean we need a bridge, or do they kind of talk natively to each other?
Yeah, we will have a kind of native bridge, or the bridge itself, bridging tokens, NFTs, whatsoever, is almost a trivial task given this inter-shard communication protocol. I will introduce on the next slide, basically. And building bridges is just one use case, or cross-shard swaps, or any kind of cross-shard applications which need contracts on multiple X-shards.
So I think, Zoltan, it's probably worth getting down to the meat of things. I think clearly, let's go for simplify and clarify. I think everyone watching, this looks like there's a few complex slides coming, but Zoltan, to be fair, does a great job in simplifying it for everyone. Well, he certainly does for me anyway. So let's go for it.
In a minute, I only have two more things to say. First of all, this inter-shard communication is for connecting X-shards, all of them being part of the Zilliqa universe. But we need more. We also need a way to talk to other chains, other EVM chains out there. And for that, we conceived and built a native bridge. It's a cross-chain bridge, so not cross-shard. It's a cross-chain bridge, which has a lot in common with the cross-shard communication or inter-shard communication. You will see in a minute on the slides. The developer interface is basically the same, but under the hood, there are differences I will introduce. And before we get into it, maybe just to set the scene for those who are not that familiar with why do we need this cross-chain and cross-shard stuff. Imagine you have two rooms full of people. The people in the same room can talk to each other directly. They just start a conversation and can talk to each other. These people are smart contracts, and you can imagine the room is a chain, but they cannot leave the room. And what if they need something from a person in the other room? They cannot leave the room and walk over into the other room. Imagine the cell phone network coverage doesn't exist, so there is no way to talk to each other unless there is some, let's call it, service staff or messengers that can deliver messages between them. So these messages, of course, are delivered with a small latency in an asynchronous manner. So you cannot have a kind of a ongoing conversation with a person in the other room, but there is a way to message each other and get a reliable delivery of those messages. And this is basically the idea of cross-chain and cross-shard communication. But let's
basically asynchronous, like a WhatsApp message across, so you get the things coming back and forth that's signed off. Is that kind of what you mean?
Asynchronous in the same way like emails. You send me an email and you wonder when does he reply, and maybe only tomorrow. So if we are chatting, then it's different. We are having a conversation right now, it's different. It's synchronous. Asynchronous is where you have to wait for the response. Good. So to the more technical slides.
Just before we go on to that, Zoltan, somebody's asking, obviously it's based around fast, hot stuff. Somebody's saying, have we talked to the founders? Just kind of want to explain how this process works.
The question was about fast, hot stuff.
Somebody said specifically, have you talked with fast, hot stuff founders? ?
Yeah. I talked a lot to one of the authors of the paper, and he reviewed our specification and everything. So there have been kind of months of intensive communication. If this was the question.
Yes.
And I know where it diverged today, and we are still in touch. So we became kind of friends, so to say.
I'm not sure whether or not the question is, are we allowed to use it? Have we had the sign off to use it? I think it's open source, and therefore
it's open source. It's an academic paper. There is no copyright or patent or whatsoever on it. Yeah.
Brilliant.
Good. So let's start with the inter-shard case. So we are inside the Zilliqa universe, and we have two X-shards, one on the left and one on the right. Both X-shards have their own consensus and validator set. As you know, these are the circles at the bottom of the slide. And there are smart contracts. These are the guests in the room. One of them, just for the sake of this example, is this caller. And this caller needs to send a message to a counterparty, to another person in the other room called the surrogate. And there is this wall between the two rooms. Luckily, there is some service staff, another smart contract, called the gateway. There is exactly one on every X-shard. And the caller contract can turn to the gateway contract and request it to send a message over to the surrogate on some other X-shard. This function call or request contains the address of the surrogate and the chain ID and a few other parameters I didn't list here. And it contains a encoded call, basically. You can imagine it as an envelope, and everything is inside the envelope. All the instructions, everything the surrogate needs to know and interpret and execute is inside this envelope. Therefore, it is boxed here. So it is basically an encoded message code. What the gateway does, it takes care of nonces on both ends. These are important for replay protection. But what it basically does, it emits an event, a blockchain event, which contains these data, so the requested inter-shard message, plus a new nonce and the address of the caller. The validators of the other shard, it's on the right-hand side, they are light clients, or they run light clients of the first X-shard, which is on the left-hand side. So they get notified about all these events. Excuse me. They know when blocks on the left-hand side, on the source X-shard, get finalized. This is important in case of every bridge that you wait for the finalization of blocks. And they have their own consensus. And the next leader producing or proposing the next block simply inserts inter-shard transactions into the own block, into the proposed block. When this block gets agreed on by, so it gets, of course, checked by the other validators. They need to agree if it's fine, and the others, they also check these inter-shard transactions if they are correct. But if the block, or as soon as the block gets agreed on, every node on this other X-shard, on this target X-shard on the right-hand side, will execute the transactions in the block. Inter-shard transactions along with the local regular transactions. The execution of the intershard transactions is a little bit special. We tweaked our EVM and protocol a little bit. This is how we use basically the advantage of our own protocol, because it consists of two steps. In one step, the gateway is asked for invalidating the nonce. It's about replay protection, as I already mentioned. And in the second and main step, the actual message gets delivered. So it's a transaction calling the surrogate with the call data that was encoded by the caller. So you can imagine it as opening the envelope and taking out the piece of paper with specific instructions for the surrogate. We set the message as sender to the call address because the caller shall pay the transaction costs and shall appear as the message sender to the surrogate. What the surrogate does is basically executing this function. This is a kind of normal EVM function with these parameters. In this case, it happens to have two target addresses, T1 and T2, and two encoded call data arguments, because in our example, what the surrogate does is to make these calls to the first target address with call data 1, and then to the second target address with call data 2, and collect some return values or an error. There might be an error revert happening during the second call. And this is it if it's just one way and if there doesn't need to be any response. Now, let me jump to the second slide, which is the continuation, basically. What if we need a response? So the surrogate wants to tell the caller by sending a message in the other direction, hey, this was the result, or the execution failed, or the call of the target contract failed, or whatsoever. Then it does the same as the caller did on the first slide. It requests the local gateway contract to send a message back. It encodes everything that needs to go to the caller in this envelope, in this call data. The gateway emits an event. Now we switched the two sides. The validators of the first X-shard on the left-hand side are the light clients of the other X-shard, so they get notified about this events. They wait until the block is finalized, of course, and they do the same basically as before. So the next leader among them injects these cross-shard transactions, the backwards going transactions into the block. The block gets agreed on, and the transactions get executed, and eventually the response message gets delivered to the caller. There are some minor details, like this ID is important in order to match the calls, from the first slide to the responses going back on the second slide. But basically, this is it for intershard transactions.
Just in terms of how quick does all this happen, Zoltan?
The only delay or the minimum delay that must incur is the finality of the blocks on both ends. So let me jump back. Before this leader inserts or injects this transaction, this cross-shard transaction into its block, it needs to wait until the block from which this event came on the source shard gets finalized. Because otherwise, the event could disappear afterwards, block gets reorganized, but you already delivered the message, not good, and someone minted a wrap token or whatsoever on the other side. But as we talked before, this finality is kind of +2 subsequent blocks, or let's say 4 or 5 seconds in the common case.
Okay.
So you need to wait this amount of seconds, and then you can dispatch the cross-shard message.
Okay.
Good. Then let's get to the cross-chain case, or cross-chain calls and responses. They have a lot in common with the cross-shard case, but the major difference is that in this case we must rely on smart contracts. So all these things that can be done in protocol or natively for the shards, for the X-shards, need to be covered by smart contracts for the simple reason that we cannot tweak or modify the EVM of other chains. So we only have the EVM and we can deploy contracts on the EVM, but we cannot do any tricks. So therefore, let me outline the differences. It starts in the very same way. There is an ongoing transaction, and this caller contract is the one that needs to send some message to the surrogate on the other chain. In this case, the left-hand side, and it doesn't matter which two EVM chains we are talking about. So the left-hand side could be Zilliqa, the right-hand side the Ethereum mainnet or Polygon or whichever other exchange, or vice versa. It doesn't really matter. The messengers in all of these combinations or cases are always the Zilliqa 2.0 validators, because even though we do not trust any individual validator, but we trust the supermajority. The same supermajority of proof of stake validators, which secure the entire Zilliqa chain. So we have the same trust assumptions as for the chain itself. And if you trust the Zilliqa blockchain, then you can trust this mechanism as well. So the caller contract requests the gateway contract deployed on the source EVM chain to send the message. The gateway contract generates or emits this event. The event is being seen by the Zilliqa validators. And what they do here is they sign this message, basically, or all the data from the event, and they exchange the signatures with each other. And as soon as the next leader, it's always kind of the next block proposal leader in their consensus collected the supermajority of the signatures, then it submits a regular transaction. We cannot do any tricks here, so therefore it's a regular transaction containing all this data from the event, plus the signatures, the collected signatures of the supermajority and the nonce, and this is it basically. And this transaction goes to the gateway on the target chain first. The gateways need to do a little bit more work in this case. They need to check the signatures. So are the signatures fine? Do they cover the supermajority, etc.? They do gas metering, so they measure the gas consumed by the surrogates and everything the surrogates do in order to refund the leader who submitted the transaction on the target chain, and of course they take care of the nonces just like before. So if the signatures and everything was fine, then the gateway calls the surrogate by opening the envelope, so to say, and delivering the message using the call data that was encoded. And the surrogate does the same as in the shard case. So it calls some other contracts, target 1, target 2, and receives some return values maybe, or errors or whatever. If there needs to be a response, last slide, I promise, then it is similar like before in the intershard case. The surrogate, in the course of the same transaction, the surrogate doesn't stop after executing these calls to T1 and T2, but it collects and encodes the collected responses and errors, and request the local gateway to make a backwards cross-chain call or send a backwards cross-chain message to the caller, back to the caller, to the source chain. Emits an event. The ZQ2 validators get informed about the event. They sign the event, exchange the signatures, collect the signatures by the supermajority, and the leader among them submits a transaction on the source chain, where the local gateway does the same job as the other gateway did on the previous slide, checking signatures and metering gas, and checking the nonces, and dispatching the results basically in this requested or encoded callback function call to the caller. So these are the similarities of inter-shard and cross-chain transactions. They are basically the same from the developer point of view, because the developer who wrote the code of these caller contracts and the surrogate contracts uses the same mechanisms, so talks the same interface to the gateway. But as you see under the hood, there are differences because, in the case of our X-shards, we can tweak the protocol. In case of other EVM chains, we must use a purely smart contract-based approach.
Brilliant. So is there any questions specifically? There's one around how decentralized the chain we're going to be. Don't know if you can see that one, Zoltan. Don't know if you want to take that question.
No, I haven't seen questions, but it will be as decentralized at the beginning, then hopefully kind of grow and become more, even more decentralized as our staking seed nodes are. So the plan is to start off with the SSNs basically being the first validators, proof of stake validators on the Zilliqa 2.0 chain. They have already accumulated a reasonable amount of stake. I guess so 1/3 of the total supply has been staked. So this provides us with a respectable amount of security, so to say. But so we are welcoming future SSNs as well, and there will be X-shards which do not even use a proof of stake, so they will have their own validators. So I guess the total group of validators on the entire chain will grow massively, but at the starting point, I guess it will be the SSNs.
Okay. So I think we're coming towards the end of time. I'm not sure if people listening in would like to ask a few more questions. Feel free to post them in the comment box. We'll try and answer them. I think one question that people are probably asking, Zoltan, Zilliqa 2.0 white paper, when available to read?
Sorry, I would like to say Christmas present, but a bit later. So we already have the draft internally circulating. End of January.
Hopefully that's acceptable to people. But yes, let's aim for end of January. I think just for people listening as well, the work obviously is commenced on Zilliqa 2.0. Timelines around when that's available, I'm not going to commit because I'll be crucified if we don't deliver against that. But the work is in progress. And as I said, I think on another conference call or podcast the other day, it's not impacting our ability to win new projects or get people to build in Zilliqa. And clearly with a pathway to Zilliqa 2.0 and what we're looking to deliver, it starts to become quite an attractive place for people to look to come and build. So hopefully that's given everyone some insight into where Zilliqa 2.0 is heading. Zoltan, I heard him commit by the end of January, he'll have a white paper that we can read, and the tech team will keep burrowing away and kind of delivering additional features as we go along. So yeah, things are looking really exciting, a lot happening, and yeah. So yeah, no need for white paper. Let that come when it will be launching. Okay, that's a fair comment. I think, yeah, we can take it internally, but we're happy to kind of share that early, just to make some people happy.
It's really available also as kind of an announcement, of exciting features so that everyone knows and understands what's coming. It will be available if you want to have a read, then you can, of course, or just wait for the launch as you want, guys. Exactly. And our engineering team has been doing tremendous work. So I Internally, we already saw this or many of this running in a DevNet, etc. And it's super exciting.
Yeah, hats off to the people actually have been building this out behind the scenes. It's kind of a thankless task at times, but yeah, we do really respect the hard work that they're putting in, along with everything else that's going on. So that's managing Zilliqa 1.0, Zilliqa 2.0, and everything else in between that everyone gets involved in. So yeah, we're pulling pretty hard, and yeah, hope you all appreciate the work that's going in behind the scenes. So. But yeah, I think that's a wrap, Zoltan. I'd just like to say, on behalf of everyone, thanks very much for giving up your time to talk us through it. I'm sure the community will be happy to hear a lot more from you. You've got a lot to talk about, a lot to say. So I think let's try and schedule in a few more sessions with yourself so we can share your knowledge with a wider community, not just the Zilliqa community. So thanks very much. And for everyone who tuned in today, gave up your valuable time to listen in to what we're up to. As always, we appreciate the support and have a great end of the year. And we look forward to catching up in 2024. Thanks very much.
Thanks for joining.
Oh, hold on. There's one question before we go. We've asked this actually. What will be the TPS and how much validators? I don't know.
Yeah, we already mentioned the TPS. So the main X-shard, yeah, it's hard to make promises. It's just the measurements we had internally, but on the main X-shard without any multi-threading or other parallelization and other tweaks, yeah, 4,000 was kind of the order of magnitude we measured. Might be a bit more, a bit less per second. Smart contract execution, not just kind of simple transfers. How many validators? I hope at least as many SSNs we already have, and later on more.
Yeah, exactly that. I think somebody's asked actually quite a good question. Amanda said, "Thank you. Will you be offering a developer bootcamp?" So I guess we're going to have things in play to get people to look to kind of build. I think we've got a few proof of values we're kind of talking around in terms of some of these X-shards that we're looking to kind of spin up. So yes, we're going to do something, Amanda. Good question. If there's no more questions, I think we'll end it there. Thank you very much.
Thank you. Cheers.